Right, here we've got some examples of finding the sine, cos and tan of angles in any quadrant. Your first step with all of these, I think, is to actually draw a quick little unit circle to locate where the angle is actually going to be, in which quadrant, and then to work through from there. So we've got cos of 180 minus theta. So we'll draw, so let's do number one. Just a quick little sketch. I think for all of these questions, a quick little sketch is the way to go. Put our CAST or all stations to central. So we know which, just remind us which quadrants the ratios are positive in. Okay, now we've got 180 minus theta. So we're working in degrees. So we've got 0, 90, 180, 270. So 180 minus theta means going back and then coming back theta. So there's 180 minus theta is there. So we write down the question, the cos of 180 minus theta equals. Now the first step, we've located where the angle is. 180 minus theta must be in this second quadrant. We then say, okay, is cos positive or negative? The only trig ratio in this quadrant is sine, so cos must be negative, so we put negative. We then write that trig ratio, and then we drop this bit. Whatever's before the theta, we just drop it and say that's equal to cos theta. And that's the end. That's it. Done. So the cos of 180 minus theta is exactly the same as negative cos theta. Number two, tan of 180 plus theta. Quick little unit circle. Put our CAST, 180 plus theta. So we're going to go all the way around to 180 and then an extra theta there. So there's my angle, 180 plus theta, is that one there. Okay, tan 180 plus theta. My first step, once again, it's the same step. We've located where it is. Is tan positive or negative? Well, tan is positive, so I could put positive, or I just leave it as it is because that's understood to be positive. Write the trig ratio. Drop everything before the theta, including the sine there. You drop that as well. So that's just equal to tan theta. So tan of 180 plus theta equals tan theta. 3, sine of minus theta. All stations to central. Now minus theta. Minus theta, the negative means we, instead of going this way for the positive, we're going to go down this way. So there is my minus theta. That's the same as 360 minus theta. Is exactly the same as minus theta. First step, we've located, drawn the diagram, located which quadrant the angle is in. We then identify which trig ratio is positive. Cos is positive, so sine must be negative. We write sine, whatever the trig ratio, you can see the pattern going on with the ones above. And then you just drop whatever's before the theta in the brackets. So we just write minus sine theta. So the sine of minus theta is minus sine theta. And the last one is the cos of 2 pi minus theta. Same sort of deal. 2 pi minus theta. Now we're working in radians. So we've got 0, and we know pi is the same as 180. So halfway between 0 and pi is pi on 2. 0 is the same as 2 pi. 2 pi is 360, so we've gone all the way around. Halfway between pi and 2 pi. So if we're going down here, halfway between pi and 2 pi is 1.5 pi or 3 pi on 2. So you should get used to be able to know where those are without having to work them out. So 2 pi minus theta is the same as if I've gone all the way around to 2 pi and then come back an angle of theta. We put our all stations to central. We have identified that cos of 2 pi minus theta is in the fourth quadrant. In the fourth quadrant, cos is positive, so I could write positive or just leave it and write the word cos. You then delete all the bit before the theta and just put cos of theta. So the cos of 2 pi minus theta is exactly the same value as the cos of theta. So you can see the steps, and the steps are the important thing. Draw a diagram. Identify which quadrant the angle is. Then have a look and see if that trig ratio you're asked to find is positive or negative in that trig ratio, in that quadrant. In this case, in this first example here, we're in the second quadrant. Sine is the only one that's positive, so the others must be negative. And then you just drop what's there and just put theta at the end. Okay, let's extend a little bit further. Without a calculator, find the exact value. Now, the exact value means we're going to leave our answer and possibly insert form. And you're not to use a calculator to find out what square root of something might be. Okay, so let's look at the tan of 135. Tan of 135. Very similar to over here. We draw a unit circle. 135. So that's 0, 90, 180, 270. 135 is somewhere between 90 and 180. So we've got the tan of 135 equals, with all of these questions, including the ones I just did before, you always work from the x-axis. So to get to 135, which is that angle there, we've got to go all the way to this one. So it'll be the tan of 180, and then we come back. So how far have we got to come back to get to 135? 180 minus, going back 45 degrees. So that's an important step. 180 minus 45 is 135. But more importantly, we have identified which quadrant 135 is in. We have then worked off the x-axis. So in this case, we're working off the negative x-axis. So all angles in here are 180 minus theta. All angles in this quadrant are 180 plus. So tan of 135 is the same as tan of 180 minus 45. We then do all stations to central, and we're in this quadrant here. In the second quadrant, sine is the only one that's positive, so tan must be negative. Negative tan, and we drop the 180 minus and just put 45. So it's negative tan, horrible n, negative tan 45. And you say, well, oh, okay, tan of 45. I think I know that one. We've got two triangles. So we've got 45, 45, and we need to know that that's 1, 1, root 2. And we know that the tan of 45 is opposite over adjacent, so that'll be tan of 45 is 1. So we've got negative 1 over 1, which will be equal to negative 1. So the tan of 135, without using a calculator, is equal to negative 1. Second one, we've got the cos of 7 pi on 6. cos 7 pi over 6. All right, this is a little bit tricky. We've got to identify which quadrant. So if we're working in radians, we've got 0, pi, pi on 2, and we've got 3 pi over 2. Now we're working in, we want an angle of something over 6, so all of these need to be converted to something over 6. Pi is exactly the same as 6 pi over 6. 6 pi on 6 is exactly the same as pi, because the 6's will cancel and you're just left with 1 pi. How do we make this as something over 6? By just multiplying top and bottom by 3. So that'll be 3 pi over 6. Now we've gone from 0 to 3 pi on 6 to 6 pi on 6. So it looks like we're going up by a factor of 3. So 3, 6. So this will be equal to 9 pi over 6. You could have just multiplied top and bottom by 3, but you can see the pattern going on. We've got 3 pi on 6, 6 pi on 6, and then 9 pi on 6. So we ask ourselves the question, where is 7 pi on 6? Well, it's going to be somewhere between 6 pi on 6 and 9 pi on 6. So it's going to be there. And to get to there, you've always got to work off the x-axis, so it'll be that plus that. So cos of 7 pi on 6 is the cos of 6 pi on 6 plus 1 pi on 6, which is just... So 6 pi on 6 plus 1 pi on 6 will give us 7 pi on 6. So that's exactly the same as 7 pi on 6. 6 pi on 6 plus 1 pi on 6. Always got to work off the x-axis. We then do all stations to central. We're looking for, see if what, we're in this quadrant here. So this is pi on 6. We're in this quadrant, and here tan is the only one that's positive. So if tan's the only one that's positive, cos must be negative. So we can write negative cos. We drop what's before the last bit, so that'll be just pi on 6. Once again, we know we can go back to our special little triangles, and that's 1, 2, root 3, 90 degrees there. And remember these this is 60, which is pi on 3, and that one's pi on 6. So what is the cos of pi on 6? Cos of pi on 6 is root 3 on 2. So that's negative root 3 on 2. So the cos of 7 pi on 6 is equal to negative root 3 on 2.